All right, so your final exam. So we're going through it's going to be on chapters 1 through 5. So what I thought we could do is spend a little bit of time kind of going over some of the previous exams, just for some of the questions that might have kind of stuck out. And like, yeah, there are a lot of questions that were missed on that one. If it'll come up. Okay, so the first exam was pretty good. That was pretty much just on limits, continuity, and then the limit definition of a derivative. But one of the ones that kind of stuck out on exam 1, and I think it was not that you just didn't know how to do it or that students didn't know how to do it. I think just some of the either some part of the definition got away from them or just a little bit of the algebra. And that was on number 5. And it was where, for what values of x does f have a removable discontinuity? If, and then there were a couple of different versions for it, but this was one of them. So the function was f of x equals 2x squared plus 14x minus 16 all over x squared minus 9x plus 8. So with this question here, this function, if you're trying to find where the x values that make it not continuous or the discontinuities, what do you have to do with the top and the bottom?
You have to factor them?
Yeah, you have to factor them out. So the denominator, that one we can factor pretty easily. That's just x minus 1, x minus 8. In the top, what I saw a lot of people trying to do is just factor it the way it is. But something with factoring is that the first thing you should always look for is pulling out what's common. So in this case, that would be the 2. So x squared plus 7x minus 8, and then you can factor the rest of it. So x plus 8 and x minus 1. And then the denominator, we're just leaving it alone because it's already factored. Okay, so one version was where are the removable discontinuities, and then the other one was where are the non-removable discontinuities. So first off, before we figure out which one is which, what are the discontinuities?
One and 8?
Yeah. And we knew that because that's what makes the denominator 0. So those are your discontinuities. And then if you simplify the function, like you can cross out the x minus 1s. And then it reduces just down to that. So in this new function here, what's the discontinuity?
8.
The 8. So the 8 is the one that stuck around. It's the one that did not get removed. So it's the non-removable. And the 1 the part that made it 0, that totally disappeared. You removed it from the function. It's no longer in there. So that is the removable discontinuity. So it was just a little bit of the factoring that got away from some people. And then some people had these flip-flopped. So it's something it's not necessarily difficult to do, but it's easy to forget, which is weird. Okay, so that one was an interesting one. Limits with the graph, those were pretty good. The limit with the table, that was also pretty good, except for number 8. So this was a combo of having a limit with a table, but having to apply it inside of a function. So there were 2 versions with this one as well. There we go. So you had a table of values, and they were all provided. You didn't have to fill anything in. Okay, so those are your x's that were given. The function values for this one was negative 0.1054, negative 0.0101, and then negative 0.001. On this side, on the far right, is 0.0953. Moving in a little bit closer was 0.0099. And then a little bit closer was 0.001. So the question was, what is the limit as x approaches 0, which lines up with your table? But instead of it being just f of x, it was e to the negative 2 times f of x. So most of the time you just had the limit as f of x, but this time you had to apply it inside of another function. So it's the same type of thing. You just got to remember that it's also inside of a function. So if it was just f of x on its own, as x is approaching 0, what are the function values getting closer and closer to?
Zero.
Yeah. So the limit of f of x as x approaches 0 is 0. So this little thing right here is going to go off to 0 for just f of x part, and then you can evaluate the rest of it. So negative 2 times 0 is 0. And then e to the 0 is usually what?
1.
1.
Yeah, I thought this question was a little I ended up getting it right, but I was a little unsure. I was like, well, it's approaching 0. And I'm like, should I plug that value in? Or is there something
Yes.
I'm missing?
No.
And I fortunately did that, but I don't know. I guess looking at it now, I'm thinking, well, no, it makes sense to plug it in, I guess, with just the notation of the limit approaching 0. And that would be the correct f of x. Again. So.
Yeah. Okay. It's like the other questions were pretty good. Most of the other ones, like in the ones where you had to evaluate a limit just kind of on its own, where it was a fill in the blank question. those were all pretty good. Some of them just had a little math error, or you evaluated like sine as cosine or cosine as sine, like you got the unit circle flip-flopped. Except for number 17. And that one was, what is the limit as x approaches? There are a couple of different versions of this one, but they were all pretty much the same type. So the limit as x approaches 4 from the right of ln of x minus 4 over ln of x minus 4 to the 6th. So the majority of these limit questions, like your goal is to be able to plug in this number, and if it comes out as an answer, then that's your answer. But if it comes out as a D and E, like the majority of these did, then you want to see if you can manipulate the function to see if you can actually plug that number in. So if it's coming out as a D and E, don't just default to that as your answer. You got to kind of play around with it and go, well, is there anything I can do, or can I graph it? Because chances are the answer is not going to be a D and E. Sometimes it is, but most of the time it's not. So with this question, you had to remember either logarithm properties, because with log properties, what are you allowed to do with the exponent?
You can stick them in front of the log. Or
Yeah.
multiply.
Yeah. Pull it down. And now that you've pulled it down, now you can simplify, because now the LNs can cancel out. And now it doesn't even matter about the 4, because everything with the variable is gone. And so you're left with just 1/6. So don't forget that the 6, it has to stay where it's originally located. So if it's in the denominator, then in your answer, it should still be in the denominator. Okay, I think the other ones were pretty decent. I think most everybody got the last question right. This class is Math 400. That is true.
Professor Jordan?
Yeah.
I mean, just looking at 17, would it be mathematically correct to cancel out the top ln and then have 1 over ln x minus 4 to the 5th? And then, because then you end up with then you end up with like 1/5 if you brought down the 5.
Yeah.
Oh, then you wouldn't be able to cancel out. Never mind.
Yeah. So it would if the 6th power was being applied to the entire thing. So if it was like this, then yeah, then you could cancel out those LNs right off the bat, or at least the one on the top. But then you'd be stuck because you wouldn't be able to pull that 5 down because the property wouldn't apply anymore. So the exponent, in order to pull it down, it has to be applied with the stuff that's inside the ln, and not the exponent on the ln itself.
Okay, thank you. That's helpful.
Yeah. Okay, so the epsilon delta stuff, that was good. Yeah, most of it was just arithmetic errors or trig stuff. Like I saw a lot of this one, cosine of 0, and I still see a lot of it. What's cosine of 0?
One.
And what I see a lot of is people evaluate it, but they're evaluating, instead of cosine of 0, they're evaluating sine of 0. Because what's sine of 0?
Zero.
Zero.
Yeah.
Yeah.
And so I see a lot of what people do is they flip flop the answers. They'll say this is 0 or this is 1. So that's pretty common. The other common one I see is this one, cosine of pi over 2. See, a lot of people put 1 for that, but it's really zero. Sine of pi over 2, that's the one. Another one that I'll see quite a bit is like inverse tangents or arctangent of -1. And a lot of students want to put that at 7 pi over 4, but it's not. So inverse tangent, it's only going, your answers can only go from negative pi over 2 to pi over 2. So when you say 7 pi over 4, that's not in the range of it. So if it's not 7 pi over 4, what is it actually?
Negative pi over 4.
Yeah, negative pi over 4. Okay, so just be a little bit careful on the trig. Just so you don't let it get away from you. Okay. All right, so then let's see, exam 2, that was just on derivatives, and all of their rules. There it is. So one of the questions,
Question.
oh, yeah?
Can you go over 22? It was the one that had, or at least on mine, it had the x plus 2 over the square root of x squared plus 1.
Is that from which exam?
2.
2? Okay. Said 22?
Yes,
Just the
22.
square root of or x plus 2 over root x squared plus 1?
Yes, it's that one.
Okay. Sure. Okay, so find the derivative of x plus 2 over root x squared plus 1. The other problem, or the other version, it was x plus 4. And it was over the same square root. All right, so if we're going to find the derivative of this, we're going to have to use not just one rule, but 2. So what rules apply?
The chain rule and the product or the quotient rule.
Mm-hmm. Yeah. And actually, you can use the product rule if you want. You can just flip this radical up and make it a negative exponent. Just depends on what you like better. Okay, did you use the quotient rule?
Yeah.
Okay, so we'll go ahead and use that. So the quotient rule is low d high minus high d low, and square the bottom, and there you go. So the low would just be that radical. And then the d high, that's the derivative of the numerator. So the derivative of the top would just be the 1. And then it's minus, and now it switches. It's the high times the derivative of the low, or the derivative of the denominator. So that's where you're going to have to use the chain rule. So for the square root of x squared plus 1, you can either think it or write it, but the radical is really a 1/2 exponent. So your 1/2 is going to pull down. We're going to decrease the power by 1. And then we need to multiply by something else.
The
So,
2x.
yeah, the 2x. Okay. And then down here, just take your original denominator, square it. So the square and the square root cancel out. So I think most people were able to get this far. Couple of just easy errors. Some people had a plus. Some had like this quantity and this quantity flipped around. Some didn't make the exponent negative. Some forgot the 2. Some forgot the 1/2. So I mean, it was just a little, like little minor things. But that definitely threw off the answer. Okay, so now we have to try to simplify it. So over here, something we can kind of automatically do is just cancel out the 1/2 and the 2. And then it's just kind of a matter of preference on what you're going to do from here. So what I see a lot of people do, professors and everybody alike, is this negative exponent, it flips, but not straight down to the denominator. It goes right under everything else that it's multiplied to. And then I'm going to change it back to a radical because I've already got this radical right here. And then on top of it is going to be your x plus 2 times your x. That was another error. Like some people forgot about the x, like they just wrote x plus 2 and this x just dropped out. So if you multiply the x to the x plus 2, that'd be x squared plus 2x. And then it's still all over your x squared plus 1. Okay, so how are we doing on this? Do you have any questions?
No, I'm good so far.
Okay. So now we got to simplify this thing because we can't leave fractions inside of fractions. So the easiest way to get rid of that situation is to multiply everything on the top and everything on the bottom by the common denominator, which in this case is just your root x squared plus 1. Because that will clear out any little fraction and then just leave you with one numerator and one denominator. Okay, so root x squared plus 1 times root x squared plus 1 is just x squared plus 1. And then if you take that same green square root and multiply it to this blue, this little blue fraction, the radicals cancel. And you're left with minus x squared plus 2x. But you can't forget that you're subtracting the whole top, not just the first term that's up there. And the denominator, you can just leave like this if you want to. So then from here, just distribute the negative. And then combine your like terms. So the x squareds cancel off. And so the top is just 1 minus 2x. And that's all the simplification that you need to do. Another answer you could put would be to kind of just combine these two things. Because you can add up the exponents. Like this has an exponent of 1. This has an exponent of 1/2. So 1 plus 1/2 is 3/2. So you can write it this way, or you can write it this way, either one. So again, most of the errors that, that I saw on this problem was the algebra. And being able to simplify like from here down to here. So it's just little things like that. So just for practice, since it is the final review, let's take this function and let's pretend that instead of saying, hey, what's the derivative? Let's find any relative extrema and where f is increasing and decreasing for this the same function. So if you're going to find any relative extrema and intervals of increasing and decreasing, you definitely need the derivative, but then what do you do from there?
Set it equal to 0.
Yeah, set it equal to 0 and find the, what are those things called?
Critical numbers.
Critical numbers. So for this function, what's your critical number? So like, in other words, what makes this either 0 or undefined?
One half.
Yeah. So 1/2 makes the top 0. What makes that denominator, or what makes this quantity, or this quantity, either one, 0, if anything?
0.
There's no value that makes any of that 0, because even if you plug in a negative, it still gets squared.
Yeah.
Yeah. So yeah, the denominator doesn't yield a result, so it's just the top. So that's kind of nice. You might have the one critical number. I can throw in that sign chart Okay, so give me any number that's less than a half. Out loud.
0,
0. And any number bigger than a half.
1,
Okay. So these are our test numbers. So where do you plug them in? Like, where are you going to test them?
in the first derivative.
In the first derivative. So if you plugged 0 into either this or this, how does it come out? Does it come out as positive or negative?
Positive.
And if you take the 1 and you plug it in for x's, how does that come out? Positive or negative?
Negative.
Okay. So those are the only things to test. So we know it's going to be increasing from negative infinity to 1/2, and then decreasing from 1/2 to infinity. And then based on this little chart here, do you have a relative max or a relative min?
Max.
Yeah. Yeah, it's a max because it switches from positive to negative. So we know the original function, so you are able to give the y coordinate. So you need to take the 1/2, go all the way back to your original function and plug it in, and then just see what it gives you. Whatever that answer is, that's your y value. So change all those x's into a half and simplify them. So 1/2 squared is just be a 4th. Okay, so let's start to simplify it. What's 1/2 plus 2?
5 halves.
1/4 plus 1.
5/4.
5/4. So we can root it a little bit. You can't root the 5, but you can root the 4. And since there's a 2 in both of the denominators, they both cancel. So you're left with just 5 over root 5. And then if you rationalized it, that'd be 5 root 5 over 5. Or just root 5. All right, nice job on that one. Do you have any questions on what we did?
No, I think it's just finding the derivative. I forgot about the extra one, the square root of the 1/2 of the x squared, square root of the denominator.
Yeah, that'll do it. Okay, so we use the chain rule, we use the quotient rule. Let's do this one. Find dy dx of let's do sine of x y plus x squared is equal to 8. So if we're going to find dy dx of this, what type of differentiation are we going to have to use?
Implicit.
Implicit. So how do you recognize when you're going to use implicit and when you don't?
When there's more than one variable.
Yeah, there's more than one variable in there. And if it's not easy to solve for one of them. Okay, so we're going to use implicit to get this out. So the thing about implicit is that every time you find the derivative of a y, you have to kind of do something extra. Like what's the extra little piece that you have to kind of just throw in there?
You have to put dy dx.
Yeah, you have to multiply by a dy dx. All right, so let's just give it a whirl. So what's the derivative of sine?
Cosine.
Cosine. And then the angle stays the same. And then we're going to multiply this entire little function by the derivative of your angle. And since it's x, y, what rule do we have to use?
Product rule.
Product rule. So the derivative of x is just 1 times y. And then plus the x stays there, and then now it's the derivative of the y, which is 1. But then since you take the derivative of that y, it's a dy dx. Okay, so that is just the derivative of the sine part. So now we have the other two terms. So the derivative of x squared, that's just 2x. The derivative of 8 is
0.
0. Okay, so there are a couple of ways you could go with this one. One way would be to distribute the cosine in there and go from there. The other way is you can move the 2x over and divide by the cosine. They're all equivalent to each other, so it doesn't really matter how you go. So what do you guys want to do? Like, what do you see? What sounds easier to you?
Subtract the 2x, divide by cosine.
Okay. So if you're going to divide by cosine, you now have a cosine in the denominator. And whenever that occurs, what does it turn into? So in other words, you can't just leave it as cosine in that denominator. You have to convert it.
Secant.
Secant.
So, Professor, do we always have to convert it into secant? We can't ever leave cosine or sine in the denominator.
Yeah, you can't leave a single trig function like that in a denominator. So if you ever give an answer of 8 over cosine of x, I would deduct a point from that because it's not fully simplified. You just say it's 8 secant. So yeah, if you have a single trig function in that denominator, you need to simplify it. And not just me either. That would be true of your Calc 2 and Calc 3 professors. All right, so let's move the y over. And then divide by x. And there you go. Another option you can do for this is you could split it. So like you could divide the x into each of the two terms. So you could say just -2 secant of xy minus y over x. You could write it that way. You'd have a different answer in terms of cosine, depending, like if you multiply the cosine through. Just kind of depends on what you did. But this answer or this one are perfectly acceptable. Okay, any other questions on implicit?
I still have a question on exam 2.
Yeah.
It was number 26.
The one with C and D.
Yes.
That one? Okay. Let's see, which one did you have? Did you have it that's differentiable at x equals 3 or at x equals 5?
It's the x equals 3.
The 3? Okay. Okay, so f is defined, it's the function below where c and d are constants. So f is differentiable at 3. What are the values of c and d? So your function was c over pi times sine of pi x, where x was less than or equal to 3. And then c squared x minus d, where x is greater than 3. Okay, so we know it's differentiable at x equals 3. So that means that the derivative is going to exist when x is equal to 3. But this is also telling you something else. Like if they say something's differentiable, then they're implying something else that they don't have to tell you.
It's continuous.
Yeah. So if you know it's differentiable, it's also continuous. At x is equal to 3. Okay, so let's do the differentiable part first, because that'll eliminate the d right off the bat. So if it's differentiable at x equals 3, that means when you take the derivative of the top one and the bottom one and plug in 3 to both of them, then you should get the same exact result. So as long as we can use the derivatives right, then we should be good to go for that one. Okay, so the c and the d are both constant, so the only variable in there is the x. So your c over pi just stays as it is. And then what's the derivative of sine?
Cosine.
Cosine. Angle stays the same, but then you got to multiply by the derivative of your angle,
Just be pi.
just as pi. Okay, so that's kind of nice, and that's kind of why that random pi was in the denominator, so that when you did this derivative, the pi's would cancel. So it's just c times cosine. Oops. Pi x. All right, so let's get the derivative of your second line. So again, the c and the d are both constants. So what I saw some people want to do is they wanted to move the square, that power, they wanted to pull it down and use the power rule on the c. But you're not doing it on the c because c is a constant. So like what's the, if I asked you for the derivative of 2x, what would you tell me?
2.
It's 2. If I asked you for the derivative of 9x, what would you tell me?
Just be 9.
9. So the derivative of c squared x isn't going to be any different,
It'll just be c squared.
just c squared. And then the derivative of d is just going to go to 0 because it's just constant. So the top line was this, that's simplified to c cosine of pi x. The second line was just c squared.
So we're setting them equal to each other because they're because of x equals 3.
Because it's differentiable at x equals 3. So the derivatives are both are going to equal each other when x is 3. So now you can plug the 3 in for the x. And then what's cosine of 3 pi?
-1.
So the left side is just negative c. Now you can move the c, the negative c over to the right. Don't divide by a c because right now, like at this step right here, what kind of equation do we have?
It's a quadratic.
It's a quadratic, so you need to set it equal to 0. Factor out a c.
So did that c just turn into a variable? Because it was a constant.
It is, but you're now solving for it. So the constant that c could equal would be 0 and -1. When you took the derivative, it was with respect to x. So any other letter that's in there is automatically a constant. All right, so you have one of the letters down. Now you have to find the second one. So now you can use the continuity part. So the continuity part just says that when you plug in 3 into both functions, you're going to get the same result. So plug in the 3 for the x. And we'll simplify down a little bit because what's sine of 3 pi?
Zero.
So that whole left side is just 0. The right side's 3c squared minus d, so d is 3c squared. So when c is equal to 0, that means d is going to equal 0. And when c is equal to -1, d is going to equal
3.
3. So those are your constants C and D that would make this function continuous and differentiable at x is equal to 3. So you could use either pair and both of them would work. So a couple of things to watch out for this one. One, and when you do the derivative, just make sure it's with respect to x, not with respect to c, x, and d. Also, the trig values. I saw a lot of cosine of 3 pi was just 0, or sine of 3 pi was -1. And then the other one was getting down to this quadratic. I don't know what it is, but somehow when students get to calculus, and I was one of them, when you see a quadratic equation, it's like other methods to solve it kind of magically appear. It's like, no, don't do that. So don't divide a variable out, just move everything over to 0 and then solve it. Because if you divide it out, what happens is that you eliminate one of your solutions and you eliminated the 0. So you missed one of the answers. Okay, let's see, do you guys have any other burning questions about exam 2? All right, well, let's move on to exam 3. So this was all that first and second derivative data. So the increasing, decreasing like we just did, but also the concavity and inflection points, Rolle's theorem and the mean value theorem. What else was in there? Optimization, limits at infinity, curve sketching. So that it was a big informational chapter. All right, let's start with this one. Where is f of x, which is equal to 3x to the third minus 36x concave up. So if you're going to start talking about concavity, which derivative do you need?
Second derivative.
Second derivative. Okay, so in order to get the second derivative, we need the first derivative. So the first derivative would be, whoops, not 27, 9 x squared minus 36. So your second derivative would just be
18x.
mhm, So just set that to 0, solve for x. So x is 0, and then you can use your sign chart again. So any number less than 0, I think most people picked -1. Anything bigger than 0, just pick 1. And then where do you test them? Like,
In the second
test-
derivative?
yeah. Yep. Put them right back in the second derivative, and then you just care about if it's positive or negative. So if you plugged in the -1 into here, that just comes out as negative. Plug in the +1, it comes out as a positive. So we just want to know where it's concave up. So any interval that has a positive on it is going to be the answer. So 0 to infinity. All right, let's try this one. The graph of y equals 5x to the 4th minus x to the 5th has inflection points at what x values? So if it's talking about inflection points, you're still going to be working off of the second derivative. Because inflection points are where concavity switches. So we still need that second derivative. So what's your first derivative?
(20x minus 5x to the 4th).
Yeah, 20x to the 3rd. It's 5. It's the 4th. Okay, and then your second derivative?
20 minus 20x to the 3rd.
Say it again.
20 minus 20x to the 3rd.
Not 20.
60
6.
x
Oh.
squared minus 20x to the 3rd.
Yeah. Okay, so then you set it equal to 0 and then solve for x. So you can pull out what's common. So you can pull out 20. You can also pull out an x squared. So that would just leave you with 3 minus x. X is 0. So your solutions for x would just be 0 and 3. So are these my inflection points, or do I have to do something else?
I mean, don't you have to check for
Yeah.
to see if the concavity switches?
Yep, you got to check to see if that concavity is going to switch at the 0 and the 3, because if it doesn't switch, then it's not an inflection point. So if this was a multiple choice question, you better believe that one of the choices was 0 and 3. And it wasn't right because you had to check them. It's like you can test -1 and 1 again, and then test 4. So if you plug in -1, in for x, does it come out positive or negative?
Positive.
And if you plug in the 1, That comes out as a positive. And if you plug in the 4, that's a negative. So it only switched x is equal to 3. So that was your only inflection point. So you got to be a little bit careful. Like if it just wants inflection points, you still got to test them to make sure that concavity is switching. Otherwise, if it doesn't, if it's like plus to plus or minus to minus, it's not an inflection point. Nothing, concavity is not switching there. Okay, so just be a little careful. Okay, do you guys have any questions you want to hit from exam 3?
I'm looking through it, Professor, right now.
Okay.
I just
All right,
had
let me-
a quick question about this problem. If
Yeah.
Are there any other requirements for inflection points, like something to do with the first derivative? I think I'm remembering, like it can't, like x equals 3 can't be dne in the first derivative or something, or am I making that up?
It has to be, well, in order for it to be a full-fledged point, it has to exist in the function. So like if you plugged in
Okay.
x equals 3 into the original function, if it's a point, then it has to spit out a y value.
Okay.
But concavity can still switch where it's a DNE, that because it can switch at a vertical asymptote. But in that case, it would not be considered an inflection point because it's not a point. It'd be like an inflection number.
Inflection gap.
Yeah, a place where concavity switches.
Okay.
But if it's a polynomial, it's guaranteed to be a point no matter what. Okay, well, while you're looking, let me talk about like number 15. Because this threw quite a bit of people. So there was some version of this problem that everybody had. So this was the function f, and it wanted you to order the following values from smallest to biggest. So like f of 1 compared to f prime of 1 compared to the second derivative at 1. Which is a little tricky because you don't know what the function is. So you can't figure out exact values for most of them. The only exact value that you can figure out is the function value, like the original, because you know that right here it's an x-intercept. So that function value is going to be 0. But for the other two, you don't know the exact values and what they are. You can only kind of figure out the signs of them. So at x equals 1, like what is the function doing? Like if we drew it from left to right or traced it, what's the function doing as it goes from left to right? Is it increasing or decreasing?
It goes from positive to negative.
Well, but the function, yeah, it is going from positive to negative. So what does that tell you? Is it increasing or is it decreasing? I'll give you a hint, it starts with a D. It's decreasing. So if a function is decreasing, what is the sign of the derivative? Is it positive or negative?
Negative.
It's negative. So you know the first derivative is negative. And then if you look at the curve, is this curve concave up or concave down?
Concave up.
Concave up. So that means
Second derivative.
second derivative is positive. So now you know how to order them. The first derivative is the smallest since it's negative. The function value is in the middle because it's 0. And then the second derivative is the biggest because it's positive. So the other versions were real similar. I think the other one, the curve was upside down, going like this, which flipped this around. So there you go. Make sure too that when you are given a graph that you understand what it is that you have. You know, does the graph represent the function or does the graph represent the derivative? And it has to tell you what it is. So just make sure that when you're looking at it, that you are looking at it in the right way. Because if I say, hey, the graph is the derivative, but then you take it as the function, then your answers are going to be totally off. All right, anything else on exam 3? Seems so long ago.
I just want to confirm. Or on negative to infinity as the slope of the function is on those specific interval.
So I didn't really get a whole lot of that because it broke up. So I don't know if that was me or if it was you.
I was just asking it. It's on 25. It was saying that F. It was saying F is concave down from negative infinity to negative 12 and 12 to infinity. I was wondering because the first derivative function has a negative slope on those intervals, right?
Yeah, it's got yeah, from negative infinity to negative 12 and 12 to infinity, the function would be concave down because yeah, the graph of the derivative is a negative slope, or the other way to look at it is the graph of the derivative is decreasing. So then it would have to be concave up from negative 12 to 12, because now the derivative slopes are positive, or the derivative graph is increasing. All right, does that make sense?
Yes.
Okay, cool. All right, or any other questions from that exam?
Number 2. I picked the option that says 0, 3, and 6, and it said the correct answer is 3 and 6 only.
So you had the one where it gave you the second derivative?
Yes.
Yeah, so 0 can't be. because 0, the signs wouldn't change. So the concavity is not switching around the 0, if I remember right. And for the same kind of reason that we looked at over here, like if you plugged in test numbers,
Okay, yeah,
like a
that
positive,
makes
positive.
that makes sense. I just missed stupid points.
I know your pain because I made them too. All right, let's go on to exam 4. If it will pull up for me, there it goes. Okay, let's talk about number 1. So in both versions of this problem, or I think it was, the answer for both of them was none of the above or none of them.
Was it because there was no plus C?
Because there's no plus C. So we talked about it in the review. We went over it in the notes and the videos. If it's an indefinite integral, if you integrate that, there is a plus C every single time you integrate. So if it's just secant of x, that can't be the correct choice. And if it was a free response, it took a point off because you left off the plus C. So the plus C has to be in there. All right, let's talk about this one. It was number 9. So the integral from 0 to k of 2kx plus x squared dx is equal to 36. What is the value of k? The other version was pretty similar. Just had a couple of different numbers. All right, so we just need to integrate, but we have to integrate with respect to x because it's a dx. So that means that the k in here is treated as a what?
Constant.
It's a constant. So the k doesn't, nothing happens to it, it just stays as it is. So it'd be kx squared plus 1/3 x to the third, going from 0 to k, and then it's equal to 36. Okay, so now just plug in your bounds. So the k goes in for all the x's. So that would make it k to the third plus 1/3 k to the third. And if you plug in the 0, that knocks everything out and you're just left with 0. And so it still equals 36. All right, what's k to the third plus 1/3 k to the third?
Four thirds?
4/3 k to the third. So it equals 36. So it gets k by itself. And then you can simplify it. So like 4 goes into 36. 9 times 3 is 27. So the k is just going to equal 3. All right, let me find one of the free response ones.
I have question number 2. Mine was find the integral of 5 over 1 plus x squared.
Oh, sure.
I put 5 ln of 1 plus x squared plus c.
Oh. So that would be right if it was, instead of having a 5 up here, the 5 was on the outside and you got a 2x on top. So in order to be an ln, the derivative of the denominator has to be the numerator. So if it was
Yep, that makes
this, that would give you the 5 ln of the 1 plus x squared plus the c. But since you're missing the 2x up there, like you can't multiply it in by a variable. So it's not going to be that format, but instead, like you could pull the 5 out.
Yeah, then it turns into that trig identity.
Yeah, that arctangent or inverse tangent. So then it would just go to that. So on the free response, that was kind of similar to number 17. So like number 2 turned into arctangent, and then number 17, that one was the ln. You just had to tweak it a little bit.
You just add the 2 and the 1/2 on the outside.
Yeah. Exactly. So yeah, then it's just 1/2 ln x squared plus 6. The other answer, or the other problem, was a little bit different, but it had the same idea. You just needed a 1/3 and a 3. But you also needed the absolute value around that one because it was necessary. This one, it's not, because x squared plus 6 is always positive. Same for the 1 plus x squared. If you left them in for this one, that was okay. I didn't take off any points, but just be aware your Calc 2 professor might be picky about it. So kind of start getting into the habit of recognizing when this is going to be positive or when it's not. Let's see. All right, anybody have questions on number 20? That was the integral from like 0 to 7 of root 49 minus x squared dx. The other version just had different numbers, but you do it the same way. So with this one, no matter what technique you would try, like a U sub, ln, inverse trig, nothing would work with it. U sub doesn't work. It gets close, but you're missing a little bit too much for it to actually work. So if you can't actually integrate this or find an antiderivative with any of the known methods, what do you have left to do or use since it's a definite integral?
Professor, I just used it was the area of a square or circle,
Yeah.
but
So
just a quarter of it.
Yeah, a definite integral always represents the area under the curve. So root 49 minus x squared, that's a semicircle going from -7 to 7. So we only want from 0 to 7, so he's right. We just find the area under there. So what's the formula for the area of a circle?
R squared.
R squared. Well, you only want a quarter of it, so it's just over 4. And the radius is the distance from the center to the edge. So it's 7. So if you square it, you get 49 pi over 4. So anytime that happens, if you don't know what the antiderivative of this is, you can always try to graph it and see if it makes a geometric shape. And if it does, then just use geometry. And if it doesn't, then there is an antiderivative that you can probably find. You just haven't figured out what it is. All right. What do you want to ask about for this exam?
Fred, can you go over number 13?
13. 13. Did you have the right or the left?
I have the left.
Or the left? Okay, so a box or a tank contains 50 liters of oil at time t equals 4. Oil's being pumped into the tank. You have values in the table. Wait, you said left sum?
Yes.
Left sum. Okay. The other version was a right sum. Okay, so if we're doing a left sum, let's get the values up here so we can see them. Whoops. T and RT. 6, 7, 7, 12, 5, and 15, 8. Okay, so we're using the data from the table to give us our sub intervals. So the first interval is from 4 to 3. So that's the distance of 3. And then we need to choose either the 6 or the 7, depending on what type of sum we're doing. So since we're doing the left, you pick the value that's physically on the left side. So if you point at it with your 2 hands, pick the one that's on the left in your left hand. So that would be your 6. And then it's the same thing all the way down. So then from 7 to 12, that would be 5. The one on the left is the 7. And then from 12 to 15, that would be 3. And between 5 and 8, 5 is on the left. So 18 plus 35 plus 15, which gives you a total of what's the total?
It's 118.
Well, with this right here, what's your total? 18 plus 35 plus 15.
68.
68. But the last sentence in the problem said, don't forget about the first sentence. So the first sentence says you already have 50 liters of oil. So whether you did the left sum or the right sum, you got to take your total and add in the 50 that was already in there to give you that 118. So for the right sum, it's pretty much this, almost the same calculations. The 3, the 5, and the 3 are still there. But then you'd be using 7, 5, and 8 here, here, and here. Okay. Do you have any other questions about exam 4?
Number 14. It's the one with the graph.
Yeah. Is your graph when it starts, is it above the x-axis or below?
It's above the x-axis.
Okay. So yours went like this.
Yes.
Okay. And it hits the x-axis at 6. Oops. 2. This is 9. Okay, so this was the graph of f. And you're given that h of x is equal to the integral from 0 to x of f of t dt, and then which of the following is true. So it's the same type of thing. You have to order some of your values just in the right way. So it was h of 6, h prime of 6, and h double prime of 6. Okay, so let's talk about h of 6. So h of 6 is going to be the integral from 0 to 6 of f of t dt. And you don't know what f is, so you can't find an antiderivative and then plug in the bounds because you don't have an actual function. However, you do know what this represents. So what does the definite integral represent?
Area.
Yeah, it's the area under the curve. So from 0 to 6, that's this area right here. And since it's above the x-axis, is that going to come out as a positive or a negative? It's positive. So h of 6 we know is positive. So that's probably going to be the biggest one. All right, so let's look at the derivative. So h prime of x, what would that equal?
Just f of x or f.
F of x, yeah. And what little thing tells us that? Like, how do we know that it's just f of x?
It's just that integral and differentiation are inverse.
Yeah, so it's that second fundamental theorem of calculus. So then if you stick in x equals 6, it gives you this. So f of 6, what does that equal? Because this is the one value you can
This
determine.
is 0.
It's just 0. So then if you had to guess as to this one, it's probably going to come out as negative since this one's positive and that one's 0.
It's also it's concave down.
Yeah, we'll just make sure. So, oops. The second derivative of h is going to equal the first derivative of f. So if you plug 6 into the function, like what is the function doing at x equals 6? Or what is f doing at x equals 6? Is it increasing or decreasing?
Decreasing.
It's decreasing. So if it's decreasing, that means it's a negative. So now you've got your order. Second derivative was the smallest. The first derivative was in the middle. And the function value was the biggest. The other version of this, the graph was upside down. So that flipped this order. So the function value was the smallest and the second derivative ended up being the biggest. All right, anything else from exam 4? I think we've hit pretty much the major errors.
Can we do number 10?
Number 10.
I believe it was the particle moving on the x-axis. Was
Oh, okay. Did you have 3x squared or the 6x squared?
3x squared.
3x squared.
Thank you.
Yeah. Okay, so your velocity. It was this one, right? This function. That's one you had.
Yep.
Okay. Okay, so what is the position of the particle when the acceleration is 0? So if we want acceleration, how do we get from velocity to acceleration?
You take the derivative of via t.
Yeah. So that would give you 6x minus 12. And we need to figure out when that acceleration is 0. So that's going to give you x equals 2. So we're going to hold on to that and we're going to use it a little bit later. So it wants to know the position when acceleration is 0. So we need to know the position when x is 2 or when time is 2. So now you need to go the other way. So you have velocity, now you have to get to position. So we're going to integrate the velocity. So what's the integral of that?
It's
Yeah,
t. It's or yeah, x to the third minus 6x squared plus c.
Yeah. So you're nearly there. You just now have to use that little bit of data. So when t is 0, the position is 40. So c is 40. So now you've got a position function. And now you can plug in your time. So 8 minus 24 plus 40 will give you 24.
I think the T tripped me up.
Oh,
Yeah.
all right, let me talk a little bit about number 24. So I don't know if you saw in the comments, I tossed out on both versions, I tossed out part B, because in one of them there was a little typo. So I just threw it out for both parts.
Is it number 23?
Or 24, sorry. So that was the one where you had a region R, and then you had to find the line that split R into 2 equal halves. So it was that part that I tossed. But I thought it was interesting that there were a lot of people that didn't really do part A, but they went on to try part B. And so I wasn't sure if it was because they missed part of the instructions, or they just didn't know how to do that part. So did you guys have, which one did you have? Did you have the e to the x or the 1 over x?
The e to the x.
The e to the x? Okay. Like, it didn't really matter which one you had, you attacked it in the same way. So part A was sketch the region and find the area of the region. Okay, so e to the x just looks like this. So we're going from ln of 2 to ln of 8. So there's your region R. And then the area, like if you want to find the area of any region under a curve, you set up a definite interval. So from ln of 2 to ln of 8. And then it's just out of your function. So even though your bounds are kind of crazy, like, oh gosh, we haven't really had many ln's in the bounds. Well, that was just, it was to help you out and make your numbers somewhat nicer. Because if you integrate e to the x, you just get e to the x. And then you're going from ln of 2 to ln of 8. And having those bounds makes it now really nice because the e and the ln cancel out. And so the area of that region, as crazy as it is just 6. The other version, the bounds were in e, but it was the same type of thing. Like you'd have ln of an e, and then they cancel out. I think that answer was 10. Okay, so for B, it's one of those things like you can edit and edit and edit, and there's still some sort of typo. So it said that there's some line in there that splits region R into two equal halves. It wants to know, okay, well, where's the line? Where's the K? So it said that the region from ln of 2 to K is 3 times the region from K to ln of 6, and what it was supposed to say was ln of 8. So that's why I tossed it, because it said a region R. Well, R goes to ln of 8, not ln of 6. But anyway, going off of what it should have said, this is how you would have done it. You would have done the integral from ln of 2 to K of e to the x is equal to 3, because this is 3 times larger than this one. And then you just integrate both of them, plug in the bounds. So e to the k, if you plug in ln of 2, it's just 2. Plug in ln of 8, it gives you 8. And then you're solving for k. So you get your k's to the same size, so swing over the 3 to the k. Put the 2 over on the right side, divided by 4, reduce it, and then take the ln of both sides. So k ends up being ln of 13 over 2. The other version, it was pretty much the same way. You just had a different function with different bounds, but the process was really similar. And your answer, I think, came out as e to the something. All right, well, I think that's about all the time I've got. So do you have any quick questions you want to ask before we go? Like in the study guide, or the announcement I made, study the previous study guides, study the exams, and if that's all you study, that should get you very well prepared. And there is no separate study guide for the final, because you have 8 pieces of things that you can all study from. I don't have to give you a 9th.
Professor,
Mm-hmm.
do you have time to talk after this?
Yeah.
Very cool.
All right. Well, I think that'll do it then for the review session. So I'll post this to my YouTube channel. And then you can email me any questions you might have. And if I don't hear from you, just good luck on the final. And I've enjoyed the class, even though I haven't been able to see really anybody. But yeah. All right, so send me your questions and good luck.
So we have one more review later, right? From 2 to 4.
Yeah, that's going to be That's gonna be with me.
Okay, got it.
Yeah.
Thank you.
Yeah.
Oh, thank you.
You're welcome. All right,
Thank you.
you're welcome.
Have a good day.
You too.